Welcome to Algebra 2. This is lesson number 12. Today we're going to be talking about relations and functions. So let's start off with the idea, the concept of relations. You have relations with other individuals. If it's a relative, that means there's some sort of connection between you and the other person. I believe we talked about relations a little bit earlier. You certainly talked about them last year as well. So let's go on to functions. So a function is a relation in which each element of the domain, or my x values, is paired with exactly one element in the range, or my y value. So let me give you an example. If I had a list of points, let's say -2, 8, 4, 0, 7, 5. That is a possible function. The reason for that is because each value in my domain, my x values, is paired with one value in my y. So this would be an example of a possible function. Now, if I threw another point in there, let's say 4, 3, now it is no longer a function. The reason it is no longer a function is because I have a single value in my domain, that of 4, that gives me two different values in my range. In one case it gives me a 0, in the other case it gives me a 3. So this would no longer be a function. So there are different types of functions. One type of function is called a one-to-one function, where each element of the domain pairs with one unique element in the range. So let me give you an example of a one-to-one function. What I had up here earlier, until I added that last point, was a one-to-one function. So if I have 5, 2, 0, 6, 3, 8. That is a one-to-one function because each element in my domain pairs with a unique value in my y. Here's where it would not be a one-to-one function. If I were to add one more, and let's say I have -2, 2. In this particular case, it is still a function because each value in my domain gives me only one value in my range. However, it is not considered a one-to-one function because now I have two x values that give me an equivalent y value. I have 5, 2, and I have -2, 2. So I have two values in my domain that give me the same value in my y. So keep in mind that if it's a function, each x only has one value of y. Those y's can repeat, just as this one did. Right? This is still a function. However, it is no longer a one-to-one function because I now have my one value of x that gives me the same value as another value of x when I plug it in. So it's no longer one-to-one. One-to-one meaning for every one domain I have exactly one range, and for every one range I have exactly one domain. It needs to go both directions. In this particular case, it does not go both directions because if I plug in a value of 2 for my y, I can get two possible values for my x. The next type of function is called an onto function, where each element of the range corresponds to an element of the domain. So this is kind of reverse function idea, to where every value in my range corresponds with a value in my domain. And then two other types, very easy. They could either be both a one-to-one function and an onto function, or they could be neither. So they could have a function that's not one-to-one, you can have a function that's not onto, you can have a function that's neither one. At the same point, you can have a function that is both one-to-one and an onto function. So let's give it a little bit of practice here by working out some examples. Let's start off with these points: -6, -1, -5, -9, -3, -7, -1, 7, and 6, 9. So what I want you to do is start out by stating what the domains are. So take a piece of paper, go ahead and write down what are the values in my domain. Then I want you to write down the values of the range. And then determine what type of function is this, if it is even a function. If it's not a function, state that it's not a function. So I've given you a little bit of time, not a whole lot of time, but I'd like to work one out with you so that we can get a little bit more used to it, and then I'll give you some problems that you can do on your own. In my domain, I have -6, -5, -3, -1, and +6. Oftentimes we will put the domain in order. So when you do your homework tonight, it is going to be helpful if you put your domain and your range numbers in numerical order. That's the way I'll have them up on the screen. It just makes it easier for grading purposes. Technically, it does not matter if you don't have them in order, but it is going to make it much easier for you to grade your homework later on. So here I have them going from least to greatest. So those are my domain. Now, what about my range? My range of values, I have -1, -9, -7, 7, and -9. If I put those in numerical order, they'll give me -9, -7, -1, and 7. If you will notice that I do have two values in my range that are the same, the -9. So what does that indicate as to the type of function? Well, since I have multiple values of x that give me the same value for y, this cannot be a one-to-one function. So it's not a one-to-one function. We do need to determine, is it a function? Well, I have values of x that give me only one value of y. So I didn't have any x values repeating. So therefore, we have to assume that based on the information given, it is a function, or at least possibility of being a function. It is not a one-to-one function. So the next question is it an onto function? And the answer to that is yes, it is an onto function because each element in my range corresponds with a domain. I don't have any values in my range that don't have a partner. So it is an onto function. Okay, this one is more of a table type where I gave you your x value and your corresponding y value. What I would like you to do is take a moment on your piece of paper, state what the domain is, state what the range is, determine whether it's a function. If it is a function, what type of function is it? Is it a one-to-one function? Is it an onto function? Is it both, or is it neither? Go ahead and take a moment, do that, and we'll come back and get the answer. So if you look at these values, my domain is 2, -1, -2, -1, and 2. Notice that I have several that do repeat. So my actual domain is just going to be -2, -1, and +2 if I put them in order. What about my range? My range is a -2, -1, 0, 1, and 2. Those are already in order. That made it a little bit nicer. You can just list them there. Now, is this a function? A function means that I have one value of x. I only get one value of y. So here I have repeated values of my x. Do I get one unique value of y? So if I plug in a 2 for x, I could get either -2 or +2 in my range for my y. Therefore, this is not a function. We also have different values when I plug in a -1 for my x. I could either get a -1 or I could get a +1. So this is not a function. Let's try one that is a graph. So as you look at this graph, figure out what the points are. I want you to write down what the domain is, write down what the range is, determine whether it's a function. If it is a function, what kind of function is it? Is it a one-to-one, an onto, both, or neither? So as you look at your domain, with a graph, it's a little bit easier because I can just look all the way over to the left-hand side and just start working my way to get them in order. So this one, I have a -3, a -2, a -1, 0, 1, 3, and 4 would be my domain. -3, -2, -1, 0, 1, 3, 4. Now, what about my range? Well, if I start at the bottom and work my way up, I've got a -3, a -2, a 1, 2, and a 4. So -3, -2, 1, 2, and 4. Now, is it a function? Well, if you notice that when I plug in a value such as -2 in my x, I get two different values in my y. So therefore, it is not a function. All right, let's try another type, one if I give you the diagram of the figure. So here you have to look at the values. This is my domain, this is my range. In this particular case, we can list the domain. It's already listed for you. In fact, it's even in order. The range, you could also list that in order. That one shouldn't take you very long because they gave you both of them in order. So my domain is -3, -2, -1, 0, 1. My range is 0, 2, 4, 6, and 8. Now, the question is it a function or not? In order for it to be function, for every value of x, I get one and only one value of y. And I drew little lines here to show the relations. Here, when I plug in a -3, I get a 0 for my range. Here, when I plug in a -2, I get a 2. Here, when I plug in -1, I get 6. Here, when I plug in 0, I get a 4. Here, when I plug in 1, I get a 6. So it is a function because I only get one value of y for every value of x that I put in. Next question is, what kind of function is it? Is it a one-to-one function? Well, a one-to-one function means for every y value, I get a unique x value. I only get one x value. If we look over here at 6 on my y, you will notice that it came from either a -1 or a +1 on my x. So it does not have a one-to-one relation. The next step is it an onto function, which means every value in my range has a corresponding value in my x. The answer to that is also no, because if you look here at the 8 in my range, it is not connected to anything in my domain. So it is not an onto function either. Therefore, we would conclude that it is neither. The next piece of our lesson deals with two different types of relations. First one is called a discrete relation. If you're discrete, that means you don't blare it out to everybody. You keep it kind of low-key, unnoticeable almost. So being very discrete. With a discrete function, it's a relation in which the domain is a set of individual points. So we have a point here, a point here, a point here, a point here, a point here. So we could literally count the number of points that are there. That is a discrete function. Points are seen, but they're not necessarily connected. There's no line connecting these. Therefore, it's considered a discrete relation. A continuous relation is going to have those points, but they are also going to be connected in some way. So you're not going to have individual points. Instead, you're going to have lines or curves. So that's a continuous relation that doesn't break. If the relation passes what we call the vertical line test, then the relation is a function. You probably have heard of the vertical line test, probably covered it a little bit last year. We're going to be looking at it quite a bit this year. So if we look at this particular relation right here, if I drew a vertical line anywhere along that, it would only touch my graph at one point at a time. Therefore, it is indeed a function. Whereas if you looked at some of our previous examples where we said it was not a function, if I were to draw a vertical line somewhere in those relations, you would have two values of y for the same value of x. Therefore, it would not be a function. So functions are going to pass the vertical line test. Along with that, I'll give you a little hint. If it is a one-to-one function, it is also going to pass a horizontal line test. Because remember, one-to-one function, for every value of y, you have only one value of x. So therefore, it would pass a horizontal line test. We'll get into that a little bit more. Let's try one of these, figure out what kind of relation it is. So for this one on the board, we have a graph. Does it represent a possible function? Well, if I take my vertical line and I go along, I'm only hitting one value, one point at any one particular time. So therefore, I would determine that this is a possible function. What kind of function is it? It's a discrete function because we have individual points. It's not connected in any way. Let's try a word problem. From 2004 to 2009, a company had 25, 28, 34, 31, 27, and 29 employees. Graph this information and determine if it is discrete or continuous. Then indicate if it is a function. So very quickly graph those values and then answer the two questions that I have there. So let's take a look at the graph. Your graph should look something similar to this. You might have a slightly different scale, but you should have those same values. Looking at this, we can see that there is only one value of y for each value of x. So it is indeed a function. It is a discrete function. Now, my next question, it goes a little bit beyond what we have written up on the board. I would ask you, is it a one-to-one function? Keeping in mind that a one-to-one function should pass the horizontal line test, or for every y value, you have only one x value. There are a couple of close ones here, like these points here are all really close, but they are different values in your y. Therefore, I would consider this even a one-to-one function. So let's review. Today we learned that a function is a relation in which each element of the domain is paired with exactly one element in the range. No repeats. A one-to-one function, each element of the domain pairs with one unique element in the range. So each value of x has a different value of y. An onto function, each element of the range corresponds to an element of the domain, so we don't have any range values that are hanging out there all by their lonesome. And we can also have both of those that fall into the category or neither one that would fall into a category. Then to finish up the lesson today, we talked about a discrete relation in which the domain is a set of individual points, not lines. If it has lines or is connected continuously, then that's considered a continuous relation. And if it passes a vertical line test, then we have a relation that is a function.